How does Gibbs phase rule work for phase changes? Imagine you're watching water boil or ice melt and wondering how many things you can change at once without messing up the process. That's where Gibbs phase rule comes in. It helps us understand how many variables we can tweak when different phases like solid, liquid, or gas are in balance. It's a simple formula but packs a lot of power in explaining phase changes. The rule is written as F equals C minus P plus 2. F stands for the degrees of freedom, which means how many variables like temperature, pressure, or composition you can change independently. C is the number of chemically independent components in the system. P is the number of phases in equilibrium, like how many different states of matter are present at the same time. This rule applies only when the system is in thermodynamic equilibrium, meaning the phases stay stable and don't change over time. Let's say you have pure water, so C equals 1. If you have two phases like liquid water and vapor, then P equals 2. Plug those into the formula. F equals 1 minus 2 plus 2, which simplifies to 1. That means you can only change one variable at a time, like temperature or pressure, but not both, without losing the equilibrium. Now, if you look at the triple point where ice, water, and vapor all coexist, P equals 3. The degrees of freedom become 0, so neither temperature nor pressure can be changed without disrupting the three-phase balance. This rule is especially useful in mechanical engineering when working with materials or fluids that undergo phase changes. It helps predict what conditions are needed for phases to coexist and how changing temperature or pressure will affect stability. For example, in designing heat exchangers or refrigeration systems, knowing these limits is key to keeping everything running smoothly. When you add more components to a mixture, like in alloys or chemical solutions, the number of components C increases. That means more variables can be controlled independently, giving engineers more flexibility. The rule ties everything together by showing how components, phases, and variables relate in a clear, straightforward way. In essence, Gibbs phase rule is a handy tool that helps us understand and predict the behavior of systems during phase changes. It tells us how many things we can change at once and still keep the phases in balance. This understanding is vital for designing efficient systems and controlling processes involving phase transformations in mechanical engineering.